For about 20 years, the word hypersonic has been used to mean the future of warfare, in the specific tone people reserve for things that are permanently 5 years away. Something that flies faster than 5 times the speed of sound, low in maneuvering, too fast and too unpredictable to comfortably shoot down. It has been a staple of anxious headlines for a generation. And for most of that time, the real obstacle has not been the one everybody talks about. Now, I should say where I stand, because this video is going to end with an opinion. I think a funding announcement this month, which looks on the surface like a dull piece of defense financial news, quietly says something more interesting than any of the missile-shaped headlines around it. It says that the hard part of hypersonics was never really the missile. It was everything required to build a lot of them, and to test them often enough to trust them. Because a hypersonic weapon is not conceptually mysterious. Go fast enough, stay low, and keep changing direction, and you defeat the assumptions that air defenses were built around. The physics has been broadly understood for decades. The difficulty was never imagining the thing. The difficulty is surviving the conditions it creates, and then doing that reliably, and then doing it affordably, which are three quite separate problems, wearing the same coat. And if you asked most people what makes a hypersonic weapon hard, they would say speed, as though speed itself were the enemy. But you know what? Speed is the easy part. A rocket can give you speed. What punishes you is everything that comes with sustained speed inside the atmosphere. The heat, the steering, and underneath both, the deeply unglamorous business of the engine that pushes it. So here is what we are going to do. First, why going fast in the air is a materials problem before it is anything else. Then, the bottleneck that almost nobody outside the industry talks about, which is not design at all. And finally, the big one. What this month's money is actually buying, and why that tells you where the real race is. First up, the heat. When you push through air at these speeds, you are not really cutting through it. You are compressing it violently in front of you, and compressed air gets ferociously hot. The surface of the vehicle can reach temperatures that would soften or melt ordinary metals. So a large part of hypersonic engineering is not about going fast, it is about not disintegrating while you do. And it gets worse because the vehicle has to steer. A warhead on a simple ballistic arc is, in a sense, just falling along a predictable curve. A hypersonic glider is deliberately flying, changing its path. And every one of those maneuvers happens while the thing is wrapped in superheated air and being hammered by forces trying to tear it apart. Guidance that works perfectly on a calm test bench has to work inside that. And then, underneath all of it, sits the least discussed component in the entire field, the motor. Most of these systems are boosted by solid rocket motors, which are, at heart, a very carefully shaped block of propellant that burns from the inside out. They are simple to fire and monstrously difficult to make well, and the number of places that can make large ones to the required tolerance is small. That is the quiet choke point. So the honest description of the problem is not a diagram of a sleek vehicle. It is three separate industrial capabilities that all have to exist at once. You have to be able to survive the heat. You have to be able to steer inside it. And you have to be able to produce the propulsion in quantity without the supply of it becoming the thing that limits you. Which brings us to the bottleneck that gets almost no airtime. And it is not any of the engineering. It is the testing. You cannot make a weapon like this trustworthy by simulation alone. You have to fly it repeatedly and watch it fail and fix it and fly it again. And flight tests of hypersonic vehicles are rare, expensive, and slow to arrange. A program that can only test a couple of times a year learns a couple of times a year. And this is the part where the comparison usually gets uncomfortable. Because the countries the United States worries about in this domain have, by most open accounts, been testing far more frequently than it has. I'm not going to put a number on that because the honest numbers are not public and the confident ones are usually propaganda. But the direction is not really disputed. Cadence has been the gap, not cleverness. Repetition, which is exactly the light in which to read this month's announcement. Kratos, a defense company that specializes in the less glamorous end of all this, received approximately $400 million in new funding from the American Department of War for hypersonic and other national security work. And the interesting thing is what Kratos actually is. It is one of the few outfits that makes both the flying vehicles and the solid rocket motors that push them. Its systems carry names like the Erinyes Flyer, and its Zeus and Aureolus solid rocket motors, along with newer efforts it calls Nemesis and Kraken. You do not need to remember any of those names. You need to notice that one company sits across both the airframe and the propulsion. Because that is the whole point of the bet. The money is described as supporting hypersonic systems, but read against the bottleneck, it is really about capacity and cadence. The ability to build more, and crucially to fly more, and therefore to learn faster. Kratos itself framed part of it in terms of easing cash flow and supply constraints, which is about as clear a signal as a company ever gives that the limiting factor was never the idea. And honestly, this is where I want to correct the usual framing, because it irritates me a little. Hypersonics gets covered as a contest of exotic vehicles, a kind of magic missile race, and every new shape gets treated as a breakthrough. But a weapon you have flown 4 times is not a weapon you can rely on, however elegant it looks in a render. The breakthrough that matters is boring. It is the 10th flight and the 40th, and a production line that can feed them. Now, to be fair, money does not instantly become cadence. $400 million is a real amount, but hypersonic test, infrastructure, ranges, instrumentation, recovery, the whole apparatus is expensive and slow to expand, and solid rocket motor capacity in particular cannot be conjured in a quarter. Announcing funding for a bottleneck is not the same as clearing it. It is a bet that you can, placed with real chips, and it will be a few years before anyone can say whether it paid. But there is a deeper reason to care, and it is not really about who has the faster missile. A weapon that arrives in minutes, that cannot easily be intercepted, and that you might not be certain carries a conventional warhead rather than something worse, compresses the time any human being has to make a decision. That is the genuinely unsettling thing here, and it has nothing to do with which flag is on the vehicle. Speed does not only defeat air defenses, it defeats deliberation. So the thing to watch is not the next dramatic silhouette pulled off a test stand and photographed against a desert sky. It is the dull stuff, motor production, test cadence, the number of flights per year. Because the country that wins this does not win it by imagining a better missile. Everyone can imagine the missile. It wins by being able to build and fly enough of them to actually believe its own hardware. And that, quietly, is what $400 million was just asked to go and buy.